All right, guys, welcome to another episode of Cuda Education. This is the Vulkan API discussion, and we are talking about instancing in Vulkan. Okay? As always, this is Cuda Education, and this is in relation to tutorial number 15. So I have the link for tutorial number 15 in the description below, and this will go through generally what I'm speaking about right now in Vulkan code. The Vulkan code was donated from Sasha Williams, and we go through the code to discuss the things that I'm going to talk about here. This video is a rough overview of some of the things that you have to tackle when you're instancing in Vulkan. Okay, so what is instancing in computer graphics? In a nutshell, it's basically making a lot of copies of the same thing and changing each thing slightly or not at all. So normally you're talking about grass in a scene. You're talking about trees in a scene. For the example that I use in tutorial number 15, it is rocks circling a planet. So we're in space. We have a star field in the background. There's a planet in the middle, and there are rocks circling the they're rocks circling the planet, and the rocks also are rotating. All right. So the instances in the scene are the actual rocks that are circling the planet. There are about 8,000 instances in it when I run it on my machine. I'm running it on a NVIDIA GeForce 1050 Ti graphics card. If you're on an Android device, it goes down to 4,000 instances. Okay. But basically, instancing is a quick and easy way for you to make a lot of copies of something, put it in a scene with just slight modifications in each instance. So for our instances, the rotations might be a little different in each instance for each of the rocks. The textures are going to be a little bit different. The color of the rocks are going to be a little bit different. That's pretty much it, right? But so we're just gonna go through, some rough things that, how the algorithm goes about doing it, and just some rough things to keep in mind when you want to do instancing in Vulkan. So, one of the first things that you do, this is in no necessarily particular order, is you have an instance vector. Now, I'll go down here. So you have an instance vector. And all an instance vector is just it's a vector with a collection of instances as elements, right? So, in our case, we have 8,000 instances for my case. So the vector will have 8,000 elements in it. Okay? And then what you do is you loop through each instance in the vector, of course, and fill with data. So again, remember the instances are supposed to represent each of the rocks, right? So you're gonna fill it with, each instance with position information, rotation information, texture information, color information, all of that stuff, right? So we create an instance vector, and then, we loop through each of the instances and fill it with data. Now, all of this rotation, position, all that stuff, it's a lot of mathematics to actually put that in, because you're trying to make the rocks move around a planet, so it's like moving around a circle, but also the rocks themselves are rotating, right? They're transforming about their individual axis or what have you, right? So they're rotating themselves. They're not all rotating the same way necessarily and all that stuff, right? So loop through each of the instances and fill it with data, right? And then there is a process where, again, not necessarily in this particular order, but you're gonna move data to GPU local memory. All right, and this is the staging buffer process. Okay, so again, all of these calculations, all of this, filling in with data, this is generally done on the CPU side. It's you're creating the vector and you're recording all this stuff on the CPU side, but you want to eventually move all of the data, once it's finished calculating, over to the GPU, because when you're accessing the data in the scene, you want it to be as fast as possible. And of course, the scene is being generated by the GPU, so you want this stuff to be in GPU local memory, right? Then we need to do, and this is where it gets tricky, we need a pipeline vertex input state, right? And as you guys should know by now, when you're talking about pipeline vertex input state, you're talking about binding descriptions plus attribute descriptions. So my understanding is that the pipeline vertex input state now is basically declaring to the pipeline and also telling the shader, okay, you're going to receive some data, and this is the layout of the data, and this is the format of the data, and this is how you process the data. So the shaders, the vertex shader is going to receive this information, and it needs some instructions on how to process the information or the data. It's going to receive some data, and it needs instructions on how to process it. So that's what the pipeline vertex input state is all about. And in a previous video, I discussed binding descriptions, attribute descriptions as it relates to the vertex input state. Okay, so you have to give the shader, Vulkan, the graphics pipeline a heads up on what it is to expect and how to process the data. And this is where you declare all that information. Again, the previous video discusses this in detail, right? And then after you do that, you create instancing pipeline. Okay, so there are about 3 pipelines in the example code in tutorial number 15. There's a Starfield pipeline, there's the Planet pipeline, and then there's the instancing pipeline. And of course, the instancing pipeline is what you use to display the rocks that are rotating around the planet and also rotating around its axis. And of course, the rocks have a color and a texture and all that stuff. So literally, it's almost like you have a scene, you have a scene, and then you have, 3 pipelines going into the scene, right? To make the image that you want, right? So that's the way I look at it, right? I mean, I might not be completely 100%, correct, but that's the way I look at it. So each it's 3 different pipelines that you're creating, and you do 3 different pipelines because you're having 3 different things that you're trying to generate in a scene, right? So that's why instancing pipeline is its own pipeline, right? And of course, it's called the instancing pipeline because you're dealing with instancing data, right? And then you also inevitably have to set up descriptor set to access data. Okay, so we discussed descriptor sets already, and obviously the descriptor set is what Vulkan uses to actually access data. So the descriptor set is the interface for you to actually access data and also the camera system. So I'll just put also camera system. So when the user zooms in or out of the scene or rotates the scene, the descriptor sets and the uniform buffer objects, all of that stuff is managed by descriptor sets, right? So this doesn't necessarily, I mean, it's related to the instancing stuff, of course, but this is how Vulkan accesses things. Now, it's sort of related to the staging buffer process, but I'm not really going to get into that right now. But yeah, so you have to set up the descriptor set to access data. And then the finale in all of this, and I'm going to do this in big letters, is to build command buffers. Okay? So we do all of this work up here, all of this preparation, all of these things up here is basically done. We're doing all of this in order to build the command buffers. Now, the command buffers is really how Vulkan works, right? You record a command buffer, you say, okay, Vulkan, I have, descriptor sets here. I have the pipeline vertex input state there. I have pipelines. I have 3 different pipelines. I want to draw all these things on the screen, right? So the command buffers, building the command buffers, which is its own kind of function, is sort of the final thing that you do in order to draw, to render to the screen, right? It's sort of the finale, if you will. And of course, we have three different pipelines that we're working with, blah blah blah. But I'm just concerned with the instancing part, okay? So this is really the key. This is the finale, and everything else that we do is in preparation for when we're writing the command buffers, so that we could draw what we need to draw on the scene and get it done. That's pretty much it. I don't know if I want to get into anything more at the moment, but I think this is a good enough review. So again, we have an instance vector, which is basically, a vector with 8,000 elements in it. We loop through it and we make calculations and we fill it in with data. So we fill it in with position data, rotation data, scale, all of that stuff. We make some calculations. We make sure we move it to the GPU local memory staging buffer process. Then we declare to the pipeline, to the pipeline vertex input state. We declare to the pipeline, what data we expect and how the layout and the format of the data is going to be. So when we push the data to the vertex shader knows how to receive the data and process it. You have to create the instancing pipeline. So remember, there are three pipelines. There's a Starfield pipeline, the Planet pipeline, and then the instancing pipeline, which has the rocks. So we create the instancing pipeline. We also set up the scripter set to access data and also process the camera system, UBO stuff. And then we build command buffers. Remember, guys, the scripter sets is mainly concerned with being able to access and update information on a per frame basis. So 60 frames per second, 90 frames per second, 100 frames per second. This descriptor set thing is supposed to be really fast, right? Because like if you zoom in and out, or if you you do some transformations or stuff, the descriptor set needs to be, it's usually dealing with read-only memory with the UBO, and it's supposed to be really fast. Yeah, so that's what I'll say. I have videos on descriptor sets too. That's free on YouTube, so definitely you guys could check that out. I'm not gonna go much more into anything. CudaEducation.com. I will have a link to tutorial number 15. Again, I say in all of my videos, tutorial number 13 is where you install the example. It's freely available on GitHub. But it's a video walkthrough of installing all the Vulkan API examples that Sasha Willems provided for us. And I have a video walkthrough, tutorial number 13, that goes through installing it. And then in tutorial number 15, I go through all the things dealing with instancing in Vulkan. And of course, I'm dealing with the algorithm that generates a planet, a star field in the background, and rocks circulating the planet, and rocks also rotating about its axis. So it's an excellent way. I think it's the best way for anyone to learn Vulkan, is to have running code on your computer. Again, I'm assuming you have a Windows-based machine with a Vulkan-capable GPU, right? So that's the only world I know, and that's the only world my video walkthroughs deal with. So I don't know about Linux and all this other stuff. All right. Hope you guys have a good day. Check out cudaeducation.com. Check out tutorial number 15 below. I will also provide a link to Sasha Williams' GitHub repository so you guys can check it out for yourself. The code is freely available. It's open source, so you're free to download it and do whatever you want with it and view it and stuff. So that's it. But guys, remember the command buffers is really the finale. You're doing all this stuff to line up everything for the command buffer so that, you know, when you submit the command buffer and it's processing it, everything goes smoothly, right? All right, guys. Thank you for watching. Have a great day.